Okay, this is the 2017 question 8, 2000 Victorian question 8. So, fluorine gas is the most reactive of all non-metals. Anhydrous, which means without water. So you've got anhydrous, liquid hydrogen fluoride. So you could work out that there was no water because it doesn't say hydrogen fluoride in solution, and it says it's a liquid rather than in solution. So you've got this hydrogen fluoride that's acting as the water. They confirm this a few times. Down here they repeat, liquid hydrogen fluoride, like water, is an excellent solvent for ionic compounds. So there's no water, there's just this stuff. In the same way that water molecules in an aqueous solution form the ions that in water and this in water. When potassium fluoride is dissolved in hydrogen fluoride, the potassium ions and fluoride ions form ions that are written as K, and normally you would write AQ, but it's KHF and FHF. So these ions are dissolved in this liquid hydrogen fluoride, which kind of tricked a lot of people. Alright, so this solution can be electrolyzed to produce fluorine and hydrogen gas. So these are our products, fluorine and hydrogen gas. These are produced fluorine and hydrogen gas. So these are our reactants and our products. And there's no water. Potassium fluoride is added to the liquid hydrogen fluoride to increase electrical conductivity. So in order for it to increase electrical conductivity, it must become ions to help in electrical conductivity. The equation for the reaction is this, so our products. Fluorine is used to make a range of chemicals, so they're just telling you how important fluorine is. That's what you're trying to make. So it's an electrolytic cell and it's used to prepare fluorine, which is a question we'll find later on. Alright, so even before we start the questions, you need to kind of work out what's going on. So you can tell you've got something has to be losing electrons. So when you look here, your fluorine, your non-metal, has its electron, so it's charged. So it could lose its electrons and become a fluorine molecule, which is sharing the electrons instead. So straight away you can see that the fluorine ions with them can lose electrons and become fluorine molecules, which are sharing electrons, and lose the electrons. So in order to form a molecule, you need two fluorine ions, and each one of them will lose one electron each. So you lose two electrons. So you can see from here, the electrons are being lost, and they're going around and being gained on that side. So straight away, you need to try and work out which way the electrons are going. It's an electrolytic cell, so if the the electrode that loses electrons undergoes oxidation is the anode. And the anode is negative for galvanic cells, but positive for electrolytic cells. So that's the positive electrode and this is the negative. So this is the cathode, so reduction happens over here, so something over here is gaining electrons. So you can see you've got hydrogen and fluorine sharing in a molecule at the moment, a liquid molecule. And then instead of sharing, you're going to make hydrogen with another hydrogen to form a hydrogen molecule. So this must break up. So if the electrons are taken off this and you form hydrogen ions and that electron is given to the fluorine to form fluorine ions, then your hydrogen can get the electrons that are coming over here and form a hydrogen molecule up there. So you need two hydrogen ions and two electrons to form the molecule. So you can see that this is going to be your reduction reaction. The fluorine that you've produced here, the negative fluorine ions, you're gaining negative electrons on this side, so you're losing them on that side. So if the fluorine can pass through this membrane, then it can balance the charge and act like the electrolyte. So the hydrogen, positive hydrogen, go up here. This is a semi-permeable membrane, a diaphragm, so it would only let the fluorine ions pass through. You notice it's solid up here, so you're making hydrogen gas and you're making fluorine gas. So you don't want the hydrogen gas and the fluorine gas to mix. So even without looking at the electrochemical series, we've been able to work out the two reactions. So fluorine ions and hydrogen ions, they don't react spontaneously. It's an electrolytic pattern, so you have to force that reaction to happen. And then you make fluorine gas and hydrogen gas, which is in the pattern, which would react spontaneously, so you have to keep them apart. All right, so without even looking at the questions, we've kind of worked out what's going on. So label the polarities. So you know the electrons going in this direction, anode, oxidation. Oxidation is the loss, oil. Quite often people forget the basic stuff. Oxidation is the loss. So it's at the anode. The anode's negative for galvanic, it's positive for electrolytic. So only 63% got the right polarities, the right direction. And then you had to write the reaction happening at the anode, this reaction. So a lot of people would have put the wrong states down here, and that's why they didn't get the 1 mark. So 78% of people probably put AQ here. They didn't read the rest of it. You could have left that off, they said, in their answers. If you'd had no states here, then they would have accepted it. But if you put AQ here, then they wouldn't have accepted it, because there were quite a few clues that there was no water present. So most people didn't get that. Suggest why the diaphragm, shown in the diagram above, is important for the safe operation of the electrolytic cell. So diaphragms are used to keep, in electrolysis, to keep the products from coming into contact, because they will undergo a spontaneous reaction, which could be explosive. So if the fluorine and the hydrogen get together, then they can react spontaneously. It's the right pattern. So for electrolytic reactions, all of the products are always products that could react spontaneously. So when I read the answers, though, I've written my answer after reading the answers, and then I went back and looked at the answers again, and they have mentioned the products. So they've got the diagram keeps the products, and then they've mentioned the actual products. So even though it's worth 1 mark, sometimes you have to write a few things, a few key ideas, in order to get the 1 mark. So they may have thought that if you just mention the products, you're a bit vague, you might not really know what the products are. You might have just learnt from off by heart that the diaphragm keeps the products apart because the products react spontaneously in an electrolytic cell. And you may have left off the explosive bit. So you've kind of mentioned products, you mentioned spontaneous, but you didn't mention the actual products for this particular electrolysis cell, and you didn't mention that when they get together, how it's safe. So when you read the answer, because you've written products and they shouldn't be in contact and spontaneous reaction, because you've written that, you might think you've written enough. So really, really be careful when you read these simple questions, that even though you've kind of written the answer, if you haven't written enough detail, you may not get the marks. All right, so this one was kind of the opposite problem. You have a lot of marks, and it's hard to say that many things. So you notice with this question, there's 3 marks. 50% of people didn't get any marks. and only 3% and 9% of people managed to get the third mark. So this sometimes happens where really there's two things that you could potentially say, and then the third thing you have to kind of really make something up, think about something extra. So explain why the carbon electrode, this is the carbon electrode, cannot be replaced with an iron electrode, an Fe solid electrode. So if you look on your electrochemical series here, then we have the reaction that's happening here is the fluorine is losing electrons. So if you replace the fluorine with iron, which is way down here, then the iron, you're wanting to lose electrons and give them to the hydrogen. But if you put the iron there, the iron is a stronger reducing agent than fluorine. It's so strong, in fact, that it will undergo a spontaneous reaction. It wants to lose electrons and give them to the hydrogen. You don't even need a power supply forcing it to happen. So the electrons would come from the iron and go around to the hydrogen rather than coming from the fluorine, which means two things. You would be, the cathode would be being eaten away, anode would be being eaten away, and you wouldn't be making the gas that the whole point of the electrolytic cell was to make fluorine. So that's the first 2 points. Iron is a stronger reducing agent further down than fluorine and would preferentially be oxidized at the anode instead of the fluorine. So the second, that would be worth 1 mark. The second mark, no fluorine, which is the gas that you are trying to make, would be produced. So now that's 2 marks. You have to think of something extra for the third mark. So they gave a mark for the fact that you were showing something about the fluorine, something about the iron losing its electrons. So if you gave a reaction or if you did something extra that showed that you understood what being oxidized meant, really. All right, and the last question. Most people got the 3 marks for this one. You can see either people didn't know what to do or they'd given up by the time they got here. So 23% of people had probably given up and thought that they couldn't do this. So even if you couldn't do the rest of it, you could probably almost do this question without doing the rest of it. 8% of people got 1 mark, but once you really knew how to do this, then you probably were able to go all the way through and finish it. So these sort of questions, even if you've given up, if you know how to do these ones, then you could probably do this anyway, which is what 46% of people do. So calculate the volume of fluorine gas. So you needed to know this equation, really. And you're working out the classic sort of electrolysis laws. So the charge can be turned into the number of moles of electrons, which when you know the reaction, it's a 1:2 ratio. You can turn the number of moles of electrons into the number of moles of fluorine, and then when you know the question's asking the volume of fluorine, so you use your equation for SLC, rearrange it correctly. Once you know the number of moles of fluorine, then you can work out the volume of fluorine because it's 24.8 litres for every mole. You needed to have the units for this particular question, and it would be 3 significant figures. They didn't mark significant figures for this though, so it needs to be at least 3. Presumably you all know how to do this. Q equals IT, so the current in amps. Your time must be in seconds, so you've got 2 hours. There's 60 minutes in each hour, and there's 60 seconds in each minute, so 60 lots of 60. 3 significant figures. And then once you know the charge, for every mole, you need 96,500 for 1 mole. So you can work out how many moles you've got. You've only got 0.1 of a mole. And this, you put what you want on the top. You want to know the number of moles of fluorine. The ratio is number of moles of fluorine to what you've got, number of moles of electrons, and you take it over that side, multiply it, it's half. Half that gives you this. Yeah, okay.